Hello students, in the previous session we did the properties of Laplace transform. One of them is the Laplace transform for periodic function. And what is Laplace transform for the periodic function? Formula is L of f of t is equal to 1 divided by 1 minus e raised to minus st integration 0 to t e raised to minus st f of t dt. This is the formula for the Laplace transform for the periodic function. We did one of the example. Now we will do the similar type example, second type example. Find the Laplace transform of f of t if f of t equal to t, which is defined in the interval 0 less than or equal to t less than or equal to a, is equal to 2a minus t for a less than or equal to t less than or equal to 2a, where f of t plus 2a is equal to f of t. Here the function f of t is t for the interval 0 less than t less than a is equal to 2a minus t for a less than t less than 2a less than or equal to 2a, and f of t plus 2a is equal to f of t. Now this is your given function which is defined in the interval 0 to a and a to 2a, and here f of t equal to f of t plus capital T. Here capital T is 2a, that means function is a periodic function with a period capital T equal to 2a, and we know the formula for the Laplace transform for the periodic function. L of f of t is 1 divided by 1 minus e raised to minus st integration 0 to capital T e raised to minus st f of t dt. Now first you have to substitute the value of capital T. Capital T is 2a, period is 2a. Then you split the interval according to the given function 0 to 2a as 0 to a and a to 2a. Then substitute the value of f of t in the given interval. Then you have to do the integration with respect to t, substitute the upper limit minus lower limit, simplify, you will get the required Laplace transform for the given function f of t. If you take the given function, this is your given function f of t as t for 0 less than or equal to t less than or equal to a is equal to 2a minus t, a less than or equal to t less than or equal to 2a, where f of t plus 2a equal to f of t. That means function is a periodic function with a period capital T equal to 2a. Then by using the Laplace transform for the periodic function, L of f of t equal to 1 divided by 1 minus e raised to minus st 0 to capital T e raised to minus st f of t dt. Now first substitute the value of capital T. It is 1 minus e raised to minus s into 2a integration 0 to 2a e raised to minus st f of t dt. You have substituted the value of capital T period as 2a. Now you split the interval 1 minus e raised to minus 2as. Now split the interval 0 to 2a according to the given function 0 to a and a to 2a. Now it is integration 0 to a e raised to minus st f of t dt plus integration a to 2a e raised to minus st f of t dt. You have splitted the interval 0 to 2a as 0 to a and a to 2a. Now you have to substitute the value of f of t in the given interval. Now it is 1 divided by 1 minus e raised to minus 2as integration 0 to a e raised to minus st into t dt. In the interval 0 to a, your f of t is t plus integration a to 2a e raised to minus st. In the interval a to 2a, your function is 2a minus t. Now substitute, it is 2a minus t dt. Now you have to integrate with respect to t, first integral, first term and second term. Now it is the product of two function, then use the generalized integration by parts. This is 1 divided by 1 minus e raised to minus 2 as it is. Now integrate with respect to t by generalized integration by parts. First function is t, second function is e raised to minus st. First function as it is, integration of second function e raised to minus st integration e raised to minus st by minus s minus differentiation of first function t differentiation is 1, again integration of second function e raised to minus st by minus s whole square. Next differentiation is 0, stop here itself from 0 to a plus similarly second integral is also product of two function. Take first function as 2a minus t, second function as e raised to minus st. Again use the generalized integration by parts. First function as it is 2a minus t, integration of the second function e raised to minus st by minus s minus differentiation of the first function 2 is constant 0, constant of differentiation is 0 minus t differentiation is 1, therefore it is minus t integration of the second function e raised to minus st by minus s whole square. Next differentiation is 0, stop here itself from a to 2a. Now substitute upper and lower limit and just simplify. What you will get? Now this is 1 divided by 1 minus e raised to minus 2s. Just ordinary simplification, upper limit minus lower limit. For the first square bracket, upper limit is a. Now it is minus a e raised to minus sa by s, then minus e raised to minus sa by s square. Now upper limit minus lower limit, minus 0 into e raised to 0 by s minus e raised to 0 by s square. Now this is the first square bracket, upper limit minus lower limit. Similarly the second one, plus minus 2a minus 2a e raised to minus s into 2a by s minus minus into minus it is plus e raised to minus s 2a by s square. Now this is your upper limit minus lower limit, minus 2a minus a e raised to minus sa by s, then plus e raised to minus sa by s square. Now, this is your upper limit minus lower limit. Now, simplify. What you will get? This is 1 divided by 1 minus e raised to minus 2as. It is minus a e raised to minus as by s first term. Second term minus e raised to minus as by s square second term. 0 into anything is 0. E raised to 0 is 1. Minus into minus it become plus 1 by s square. Now, second square bracket 2a minus 2a is 0. 0 into anything is 0 plus e raised to minus 2as by s square. Then minus into minus it is plus a e raised to minus as by s, minus into plus is minus e raised to minus as by s square. Now, it is ordinary simplification. The first term and last but one term plus and minus it will get cancels. Now, just simplify. What you will get? Ordinary simplification. You have to do the simplification very carefully. Denominator s square is common. What you will get? This is 1 divided by 1 minus e raised to minus 2as. Denominator s square is common. Then it is plus 1 is there. You can write 1 minus sign e raised to minus as. Here also e raised to minus as. Therefore, it is 2 times e raised to minus as. Then we left this one plus e raised to minus 2as. Now, once again further you can simplify similar to the previous example. Now, you can write this one as 1 plus e raised to minus as, 1 minus e raised to minus as. How you have written this one? By using the algebraic formula a square minus b square, a plus b into a minus b. Then how you write this one again in the algebraic formula? 1 minus e raised to minus as whole square. It is nothing but a minus b whole square, a square minus 2ab plus b square, and denominator s square as it is. Now, further simplify. How to simplify? I told always the result should be in the simple form, not so complicated or not too big also. Now, you can 1 minus e raised to minus 1 is to get cancels. It is 1 by s square, 1 minus e raised to minus as divided by 1 plus e raised to minus as. Further, you can simplify. How to simplify? Here multiplying and dividing by e raised to as by 2, e raised to as by 2. You can write still further in the simplified form. If you take inside the bracket e raised to minus e raised to as by 2 minus e raised to minus as by 2 divided by e raised to as by 2 plus e raised to minus as by 2. If you take e raised to as by 2 inside the bracket for numerator and denominator. Now, how to write in the simplified form? It is nothing but tan hyperbolic as by 2. That means you have written the result in the very simple form in terms of hyperbolic function by making adjustment in the function, multiplying and dividing by e raised to as by 2. Like this, you have to do the example on Laplace transform for periodic function. Yes, now let us move on to the next property. Now we did 5 property. First one is the linearity property, second one is the first shifting property, third one multiplication by t raised to n, fourth one division by t, and fifth one we did Laplace transform for periodic function. Now the sixth property is the unit step function. Unit step function, it is also known as Heaviside unit function. Unit step function is also known as Heaviside unit function. Now, how will define the unit step function or Heaviside unit step function? Now, the unit step function, it is denoted by u of t minus a, or you can write h of t minus a, and is defined as 0 for t less than or equal to a, is equal to 1 for t greater than a. This is the definition of the unit step function, or in general we call it as step function or Heaviside unit step function. Now, the Laplace transform of the unit step function is e raised to minus as by s. Laplace transform of the unit step function is e raised to minus as by s. Now, here we can prove this one just by using the definition of Laplace transform. Then next one is the second shifting property. Second shifting property. What is this second shifting property? If L of f of t is equal to f of s, if the function f of t is multiplied by the unit step function, and if you take its Laplace transform, function is multiplied by unit step function, and if you take its Laplace transform, it is e raised to minus as L of f of t plus a, e raised to minus as L of f of t plus a. Now, t changes to, in the function t changes to t plus a. This is the formula you have to remember. This one also we can prove by using definition of Laplace transform only, very simple proof. Then for a given function, how to write in terms of unit step function. If you first one is, if the function is f of t is f1 t, which is defined in the interval 0 less than t less than a, is equal to f2 t for a less than t less than b, or if you take t greater than a, if you take f1 t for 0 to a and f2 t for t greater than a, then you can express this function in terms of unit step function. How you are writing f of t equal to f1 t first function plus f2 t minus f1 t into u of t t minus a. Now, you have written the given function in terms of unit step function. Similarly, for the where the function is defined in 3 intervals. One is f1 t for 0 less than t less than a. Another function f2 t is defined in the interval a to b, and third function f2 t is defined t greater than b. How you are going to write this one in terms of unit step function? Now, f of t equal to f1 t plus then difference of the second function and first function f2 t minus f1 t into u of t minus a plus again difference between the third and second function f3 t minus f2 t into u t minus b. You must remember these formulas to express the given function in terms of unit step function. Where the function f of t is multiplied by the unit step function, you can use this property, second shifting property, that is e raised to minus as L of, then the function changes to f t to t plus a, f of t plus a. Yes, based on this property, second shifting property, we will do some of the examples. Yes, now here are the example. Express the following functions in terms of unit step functions and hence find its Laplace transform. First one, f of t equal to t square in the interval 0 less than t less than 2, 4t for t greater than 2. Second one, f of t is cos t defined in the interval 0 less than t less than pi and sin t for t greater than pi. Whereas third one, f of t is cos t for the interval 0 to pi, cos 2t for pi to 2 pi, cos 3t t greater than 2 pi. Now, here there are two parts. First part, you have to express the given function in terms of unit step function. Then second part, you have to find its Laplace transform. You have to find its Laplace transform. Now, how will do the example? First two example by using this formula you have to do. Second one, this one for the three functions. Then after that, you have to second part you have to find the Laplace transform. Yes, we will do the first one. First example, given f of t equal to f of t which is defined t square for 0 less than t less than 2 is equal to 4t for t greater than 2. First part, you have to express the given function in terms of unit step function. How to express? Here it is defined in the 0 to 2 and t greater than 2, as I told, which can be expressed in terms of unit step function as below. Now f of t is equal to, now the first function is t square as it is, plus difference between the first and second function 4t minus t square into u of t minus 2. Now here is to u t minus 2. Now this is your first part. Then second part, you have to find the Laplace transform, that is L of f of t. You have to find out L of t square plus L of 4t minus t square into u t minus 2. Now we know this one, this is the basic standard formula. L of t raised to n, formula is n factorial divided by s raised to n plus 1. You must remember the formula. It is 2 factorial by s raised to 2 plus 1 plus, how to find the Laplace transform? Here the function f of t is multiplied by the unit step function. By using the Laplace transform, how you have to find out? By using the second shifting property. F of t is multiplied by unit step function L of f of t u t minus a. What is e raised to minus a s? E is 2 here, e raised to minus 2s into L of 4 into t plus 2 minus t plus 2 whole square. Now t changes to t plus a. Now simplify. What it is? 2 factorial by s cube plus e raised to minus 2s L of, it is 4t plus 8. Now it is a plus b whole square, a square, outside minus is there, t square minus 4t minus 4 minus 4. Now plus 4t minus 4t will get cancels. Now this is equal to 2 factorial divided by s cube plus e raised to minus 2s L of 8 minus 4, it is 4 minus t square. Now it is 2 factorial by s cube plus e raised to minus 2s. Now 4 is constant. What is L of 1? L of 1 is 1 by s minus again L of t square, again L of t raised to n, n factorial by s raised to n plus 1. Therefore it is 2 factorial by s raised to 2 plus 1, or you can write 2 divided by s cube, 2 factorial, 2 into 1, e raised to minus 2s, it is 4 by s minus 2 by s cube. This is your required Laplace transform. Yes, now we will do the second example, which is a trigonometric function. Second example, which is the trigonometric function. What is given? F of t is cos t in the interval 0 to pi, 0 less than t less than pi, is equal to sin t for t greater than pi, t greater than pi. Now how given function is a trigonometric function which is defined in the interval 0 to pi and t greater than pi. How to express? First part, which can be expressed in terms of unit step function as below. F of t, first function you can keep it as it is, cos t, plus second function sin t minus cos t, difference between first and second function into u t minus pi, a is here pi. 0 to a and t greater than a. Now you have to find its Laplace transform. How you are finding? L of f of t equal to L of cos t plus L of sin t minus cos t into u t minus pi. U t minus pi. Now here first term it is standard form L of cos a t, s divided by s square plus a square, s divided by s square plus 1, a is 1 here, plus how to do this one? Second term, it is function is multiplied by the unit step function by using the second shifting property u t minus a. What is your formula? E raised to minus as, e raised to minus pi s, L of sin t plus pi, t changes to t plus a is here pi, minus cos t plus pi. Now this is s divided by s square plus 1, first term as it is, plus e raised to minus pi s L of, now simplify, it is a trigonometric function sin t plus pi, 180 minus 180 plus theta, it is minus sin t only. Third quadrant sin is negative. Now here also cos of pi plus theta is minus cos theta, minus into minus plus cos theta is also in the third quadrant. Now you can write s divided by s square plus 1 plus e raised to minus pi s L of L of minus sin t, first term minus sin L of sin a t, standard formula a divided by s square plus a square minus sin as it is 1 divided by s square plus 1 square, it is 1 only, plus it is L of cos a t, s divided by s square plus a square, s divided by s square plus 1. Or you can still further you can simplify s divided by s square plus 1 plus e raised to minus pi s. You can take LCM, you can write it as s square plus 1, and here you can write s minus 1, s minus 1 divided by s square plus 1. This is the second example where the function is defined in the two intervals. Now we'll do one more example where the function is defined in the three interval, where the function is defined in the three intervals. Defined in the three interval. What is your given function? It is cos t. Cos t for 0 less than t less than pi, cos 2t for pi less than t less than 2 pi, cos 3t for t greater than 2 pi. Here the function is defined in the three intervals. Now how to write the given function in terms of unit step function? First function as it is, cos t, plus similar to the second example, difference between the first and second function into u t minus pi, plus for the third function minus second function into u t minus 2 pi. Like this you have to express the given function in terms of unit step function. Now the second part you have to find its Laplace transform, L of f of t. This is L of cos t plus L of cos 2t minus cos 2t into u t minus pi plus third term L of cos 3t minus cos 2t into u t minus 2 pi. You have taken Laplace transform on both sides. Now, what is the first term? L of cos at, one of the standard formula, s divided by s square plus 1. L of cos at, s divided by s square plus a square, a is here 1 plus. Now, the second and third term function is multiplied by unit step function u t minus a is here pi. You have to use the second shifting property, e raised to minus as is pi, then L of cos 2 into t plus pi minus second function minus first function cos t, cos of t plus pi, then multiplied by unit step function. Unit step function already have taken e raised to minus pi s, e raised to minus as L of f of t plus a, t changes to t plus a, that is t plus pi. Then second term u t minus a is here 2 pi, e raised to minus 2 pi s L of cos 3 into t plus 2 pi minus cos 2 into t plus 2 pi. Now, simplify. What you will get? First term as it is, there is no change in the plus e raised to minus pi s L of. Now, simplify cos 2t plus 2 pi, it is nothing but cos 2t only. What about this one? Cos of t plus pi, cos 180 plus theta, it is third quadrant, it is negative, minus into minus plus cos t, then plus e raised to minus 2 pi s L of. What is the third term? Simplify cos of 3t plus 3 into 2, 6 pi, cos 3t plus 6 pi, it is nothing but cos 3t only, minus what is this one? Cos 2t plus 4 pi, 4 pi plus theta, it is in first quadrant, therefore it is cos 2t only. Now, just take the Laplace transform. What is s divided by s square plus 1 plus e raised to minus pi s into L of cos at, s divided by s square plus 2 square, 2 square is 4 plus 1 divided by s divided by L of cos 80, s divided by s square plus 1 square, a is here 1 plus e raised to minus 2 pi s L of cos 80, a is here 3, s divided by s square plus 3 square, that is 9. What about the last one? Minus L of cos 80, s divided by s square plus a square, that is 2 square, that is 4. Yes, this is your required Laplace transform. Here, by using expressing the given function in terms of unit step function and by using the second shifting property, we got the Laplace transform for the given function which is defined in the sum interval. Yes, this is about the Laplace transform. Based on the properties of Laplace transform, we did the examples. This completes about the Laplace transforms, and here we did the definition of Laplace transform. L of f of t integration 0 to infinity e raised to minus st f of t dt. Then after that we did some basic standard formulas in the Laplace transform. Totally there are 7 formulas. L of 1, 1 by s, L of e raised to at, 1 by s minus a, L of t raised to n factorial by s raised to n plus 1, L of sin at, L of sin at, a divided by s square plus a square, L of cos at, s divided by s square plus a square, and hyperbolic function L of sin h at, a divided by s square minus a square, and L of cos h at, s divided by s square minus a square. Then after that we did the properties. Totally we did 6 properties: linearity property, first shifting property, then multiplication by t raised to n, division by t, Laplace transform for periodic function, then second shifting property. Only important is identification is important, which property you have to use. Easily we can understand, identify for a given function. If the given function f of t is multiplied by the exponential function, you can use the first shifting property. If the function f of t is multiplied by t raised to n, you can use the multiplication of t raised to n formula. If the function f of t is divided by t, you can use the division by t formula. If the function f of t is periodic function, you can use the Laplace transform of periodic function formula. If the function f of t is multiplied by the unit step function, you can use the second shifting property formula. You can easily identify it. If the function is multiplied by the exponential, you can use the first shifting property. Function is multiplied by t raised to n, you can use the multiplication by t raised to n formula. If the function is divided by t, you can use the division by t formula. If the function is periodic function, you can use the Laplace transform of periodic function formula. If the function is multiplied by unit step function u t minus a, you can use the second shifting property formula. Then you can do any type of example. This way you can remember when you have to use the properties of Laplace transform. Okay, in the next class we will discuss about the inverse Laplace transform. Thank you.